Alright, so this section 6.6 is about the review for the factoring. Okay, so just to remember in the last 5 sections, all of this section is chapter 6. What do we have done? We learned about how to find what? The greatest common factor, right? We also learned about how to factor what? A polynomial with 4 terms by grouping, right? We learned about how to factor a polynomial with 3 terms, which is trinomial, by either using what? Grouping method or by using FOIL method, right? And then in the last section 6.5, we learned about how to factor what? Binomial, by using the difference of square formula, right? Alright, so if we're going to summarize about how to do factoring questions, okay? At first, this is very important, okay? I think I mentioned this many times, okay? When we have a greatest common factor, okay, always factor, when we're doing a factoring question, okay, always factor the GCF at first. If we have the GCF, always do this, okay, always, okay. This is like the very basic step, the very first step for the factoring question. No matter it is a binomial, trinomial, 4 terms, whatever. If there is GCF, always factor out the GCF. The GCF is a common factor for every term from a given polynomial. Okay, so you're not saying, it is a common factor for some of the terms, but not for every term. No. GCF must be a common factor for all of the terms given. Okay, all of given terms. Okay, and it is the greatest common factor. This is the first step. Then how to factor, guys, depends on whether the polynomial is a binomial or trinomial or has 4 terms, right? So if the binomial has 2 terms, after we factor the GCF, we can use what? Difference of square formula. Remember the a squared minus b squared, right? Only when we have difference of squares we can factor. How about when we have a sum of difference? Sum of the squares. Are we able to factor? See the example. Let's factor 9x squared plus 64. Are we able to factor this binomial? Think about it. Factor 9x squared plus 64. Any greatest common factor between 9 and 64? No. And then, 9x squared, it is a 3x squared, 64, it is 8 squared. Are we able to factor this binomial? Yes or no? No. So this binomial is what? Prime. Any polynomial which is not able to factor at all, okay, is called prime. Let me ask, how about we factor a GCF? It is also called factorable, okay? As long as there is this GCF, we are able to factor the GCF, but no way to keep on factoring further. It's also not called prime. The prime is what? We're not able to factor at all. It's called prime. Okay, prime.
So wouldn't I be a prime as well, since I'm looking at it?
This one?
I.
You're talking about I?
Yeah, should.
We're not talking, okay, you're kind of in advance, okay? I'm still talking about binomial. Let me do this, in order, okay? So we'll talk about the I, okay? I'll show you I, okay? So for the binomial questions, okay? If there's no GCF, it's not a difference, then it's prime, okay? How about for binomials, okay? It is a difference. Check the GCF first. If not, if there's no GCF, see whether these 2 terms are what? Perfect squares. So let's look at question C. Are we able to factor this binomial? 36x squared minus 49. Can you give it a try? What do you get, Jose?
I got 6x squared minus 7. Or do you want to do like the 2 groups?
It is 6x squared minus 7 squared, right?
And then 6x plus 7 in parentheses.
6x minus 7. Okay? Good. Can you try number D, please? See whether there is GCF or not. What is your GCF? Do you have any GCF in this question?
3?
3? Just 3? So both term has a variable y, right? 3y. So factor out 3y, it gives us what? What do we have here? Do you get 4x to the 4th power?
Yep.
147 divided by 3. 49. Y to the cube divided by y squared. Right? Is this the difference of squares? 4x to the 4th power can be written by what? 2x squared squared. 7y squared. Oh, 2x squared squared. 7y squared. Right? So this is A, this is B. 3y times 2x squared plus 7y times 2x squared minus what? 7y. You guys? For binomial, okay? Yeah, for binomial we do it like this, okay? GCF always at first. Then see whether it's a difference of squares or not, okay? Alright, now let's look at if a polynomial is trinomial. What should we do? Same thing. Factor out GCF at first. Then see whether we're able to keep on factoring it either by formula or by for you method or by grouping method, okay? So let's give it a try for question H. X to the cube y minus 24 x squared y squared plus 9 times x y to the cube. What is the GCF? 3? 16, 24, 9, there's no GCF for number, right? I would say 1, right? 1. X to the cube, x squared, and x. Keeps at least the exponent x, right? Y squared, y to the cube. Y. So fact out the xy. We have these little policies. Cameron?
4x squared, like, 4x squared,
4x squared.
oh no, wait, cube, sorry.
16.
Wait,
This is 1, right?
that's so simple, sorry.
X to the cube divided by x squared. Y divided by y is no y, right? The middle term should be what?
Negative 24.
4xy. 9 over 1 is 1. X divided by x gone. Y squared divided by what? 9y squared. Right? Okay, for this trinomial, let's check whether we're able to use formula or not. Are we able to use formula? Let's check. Do you have two perfect squares? 16x squared can be written by 4x squared, 9x squared, or y squared can be written by 3y squared, right? If the middle term exactly equals twice times by 4x times by 3y, 2 times 4x times 3y equals 24xy?
Yes.
Yes, it is a negative. So what are the a and b's? A is 4x, b is 3y. So according to the formula, how can we factor this trinomial? What do we do, guys? 4x minus 3y times by what? 4x minus 3y. You guys agree with this? Yeah? Cameron? Alright, let's try another trinomial question. Okay, see? GCF always at first, and then see whether we can use formula, and then sometimes we may not be able to use formula, and then let's see what can we do about that, okay? So let's come to the next page, okay? And let's try question I that Jose just tried. X squared minus x minus 35. No GCF, right? It's a trinomial. Are we able to use the formula? No. 35 is not a perfect square, right? So we have to use that formula method or what? The
No, not yet.
formula method or grouping method to see whether it's factorable or not. So just now, Kevin said it's prime. What do you think?
Yeah.
Prime, right? We're not able to factor it. Okay, yes, you're right. Okay, you're right. Alright, let's try another question. Okay, I'm going to let you try the number O. Follow the instruction we just had. If there's GCF, factor out GCF. And see whether we're able to use formula or not. If not, use formula method or grouping method to factor this trinomial. Give it a try, please. any suggestion? Jose?
I think I'm wrong, but
Yeah, it's okay. Everybody make mistake. I make mistakes sometimes, so don't be hesitant.
I did 2 parentheses 2x squared plus 9x minus 5.
Okay.
Oh
Then
my god.
zero. Okay, yeah, good. So you factor out the GCF, and then for this trinomial, we're not able to use formula, right? Because 2x squared is not a perfect square. Negative 5 is not a perfect square, right? So no. Are we able to use Fourier method to give it a try? So how to use Fourier method? It wasn't here. Factor out the 2x squared by what? X times by 2x. Factor the negative 5 by two factors. Then we put those two factors inside of these two parentheses, one in each, okay? And see whether the middle term matches or not. So negative 5 can only be factored to be 1 and negative 5, or what? Negative 1 and 5, right? So let's give it a try. So I would say, how about negative 1 and 5? Let's check whether this works or not. Negative 1 times 2x, 2x. X times 5x gives us what? 5x. Oh, sorry. Negative 1 times 2x is negative 2x. X times 5 is 5x. Is the sum equals 9x? No. Okay. So how about we can switch, right? Switch negative 1 and 5. How about we put a positive 5 here and negative 1 here? Well, this time work. 5 times 2x. What do we get? 10x. 1x minus times negative 1 give us what? Negative x. So 2x plus negative x equals 9x. Yes or no?
Yes.
Yes, done. See? We can factor this trinomial by x plus 5 times 2x minus 1. We have to give it a try sometimes. Sometimes we may not exactly to get the correct answer as the first time. We have to trial and error. Okay, yeah, it's check and try, whatever. Okay, whatever you call it. If you forget about how to use this method or the grouping method to factor the trinomial, I would strongly suggest you review section 6.3 and section 6.4. Okay? Alright, so this is a factor trinomial. Okay? How about we factor a polynomial with 4 terms? Yeah, see the example. Let's try the number f. It has 4 terms. To factor a polynomial with 4 terms, same thing. If there's GCF, factor out GCF. If there's no GCF, what do? Well, after we factor GCF, for 4 terms polynomial, we can only use one method. What is method? Grouping. Grouping is the only method for a 4-term polynomial, okay? So 4 terms, let's do grouping, okay? So we can form the first 2 terms. Let's see, x cubed plus 6 times x squared. Any common factor between those 2 terms? Just x cubed and 6x squared. Any common factor? X squared, right? X plus 6. Then for negative 25x, negative 150, any common factor? I would say negative 25, right? So we can get an x. Negative 25 times what equals negative 150? Well, negative 150 divided by negative 25 equals what? Positive 6, right?
Yes.
Oh, see, we kind of group, okay, the 4 term into a pair of 2 and 2, right? Oh, now we have this term and this term. Any common factor between these 2 terms? This is x plus 6, right? So now x plus 6 becomes a common factor, right? So are we able to factor out the common factor x plus 6? Yes, we do. And from this term, we have an x squared. And then from this term, we have a negative 25 left. Can we say we completely factored this polynomial? Are we able to keep on factor? X squared minus 25 can be written by x squared minus 5 squared, right?
Yes.
So, x plus 5, x minus 5. This is completely factored. Do you agree with me? You guys? Okay, let's try another question by yourself. Please try question G. It has 4 terms and see what we can do about it. Cameron, how about you tell us?
I'm still trying to work on the first part.
Did you group them into 2 terms and 2 terms?
Not yet. Like, I try to get to...
You try to find the greatest common factor. So for the x to the 4th power, what is the coefficient? 1, right? The coefficient for x to the 4th power is only 1. So for the number, GCF is only 1 because this term only have coefficient 1, right? And then for x to the 4th power, x to the cube, x squared, for these 2 terms they have what? X variable. But does this term has an x variable? No. So do we have GCF for this question? No. There's no GCF. Then we do it for 2 terms and 2 terms, right? So Jose, how about you keep on telling us? So when we grouping the first 2 terms, what is the common factor from the first 2 terms?
X3.
X to the cube. So we can get x what?
Parentheses x plus 4.
Okay. And then from these 2 terms, any common factor?
125
125. So we get x what?
plus 4.
Plus 4. And what do we do next?
X plus 4 parentheses x 125.
Yes, you're right. Okay, actually, 125 can be written by 5 to the cube. So this is x to the cube plus 5 to the cube because we didn't learn the sum of cubes. So that's why we can stop here, okay? Yeah. But technically, we could keep on factoring this binomial, okay? But we'll stop it here, okay? So, guys, if we summarize, do you still, have a good idea about how we do factoring? What do we do at first? How about you tell me? What do we do at first? If there's GCF, always factor GCF. Whatever this, polynomial is binomial, trinomial, 4 terms, doesn't matter. Then if it is a binomial, what do we do? see whether it's a difference of perfect square or not, right? And then for trinomial, what do? If whether we can use formula or not, right? Or we use what? For you method or grouping methods, okay? And if we have a 4 terms polynomial, the only way we can do factor is what? Grouping, okay? 2 terms and 2 terms grouping, okay?